NASA's Mars rover uncovers a mind-blowing discovery on Mars that could change everything. The exploration of Mars has captured human imagination for decades, and recent developments from NASA's Mars rover missions may be reshaping our understanding of the red planet. The latest findings from the Perseverance rover, NASA's cutting-edge robotic explorer, have unearthed surprising evidence about Mars's ancient environment and its potential to harbor life. This new discovery is not only a breakthrough in planetary science, but also pushes the boundaries of what we thought was possible beyond Earth. Since landing in Jezero crater in February 2021, Perseverance has been busy exploring, sampling, and analyzing the Martian surface with a suite of advanced instruments. But recently, it made a mind-blowing discovery: preserved organic compounds in the Martian rocks and soil, and signs of a previously unknown geothermal environment. These findings provide compelling evidence that Mars once had the ingredients needed to support life and reveal complex interactions between water, minerals, and perhaps even biological processes billions of years ago. Mars, a brief background of humanity's fascination. Mars has been the focus of human curiosity due to its Earth-like qualities, as well as its unique position as the next viable location for human exploration. Mars is the fourth planet from the Sun, and, while inhospitable today, it bears signs of a past climate that could have supported life. Earlier missions provided tantalizing hints of water in Mars's past, with dry river valleys, polar ice caps, and mineral formations that likely needed water to develop. The search for life on Mars goes back decades, fueled by both scientific curiosity and philosophical implications. Scientists have long suspected that, if Mars once had liquid water and a thicker atmosphere, it might have supported simple forms of life. NASA's Perseverance rover was launched with this very goal: to search for signs of ancient life in Jezero crater, which is thought to be an ancient lake bed, potentially full of sedimentary rocks that could preserve traces of life. The Perseverance rover and its mission goals. Perseverance is one of the most sophisticated rovers ever designed by NASA, carrying tools specifically made to search for signs of ancient life. Its primary mission goals include searching for biosignatures in areas of the Martian surface where water once existed, collecting and caching rock and soil samples for future retrieval by another mission, allowing these samples to be brought to Earth for detailed analysis, characterizing Mars's climate and geology to lay the groundwork for future human exploration, testing oxygen production technologies through an experimental tool called MOXIE, essential for future human missions. The discovery of organic molecules by Perseverance is a milestone for these mission goals, offering compelling evidence that Mars once had the potential to support microbial life. Uncovering organic molecules on Mars. One of the most significant findings from Perseverance involves the detection of organic molecules in Jezero crater's sedimentary rocks. Organic molecules are compounds containing carbon, and they are the building blocks of life as we know it. While the presence of organics doesn't necessarily prove the existence of past life, it is a fundamental requirement for it. The instruments aboard Perseverance, specifically Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, detected complex organic molecules that might be biogenic in origin. These organic molecules are embedded within rock layers that date back billions of years. The fact that they've been preserved for so long raises significant questions about Mars's early environment. Conditions in Jezero crater might have been ideal for life at some point in Mars's history, with organic molecules potentially forming through biological or non-biological processes in an ancient Martian lake. This lake, surrounded by mineral-rich rocks, would have provided a stable environment for these molecules to form, bond, and, perhaps, catalyze simple life processes. The role of ancient water in Mars's geothermal environment. One of the most exciting aspects of Perseverance's findings is the suggestion of ancient geothermal activity on Mars. While scientists knew that water once flowed on the Martian surface, Perseverance's data indicates the possibility of volcanic or hydrothermal activity. In Earth's oceans, hydrothermal vents support diverse ecosystems in total darkness, providing warmth and essential minerals for life. A similar geothermal system on Mars could have created an environment where life could arise and thrive, even as surface conditions became inhospitable. Perseverance has observed mineral deposits in rock formations that could be the result of geothermal activity. If Mars had such active environments in its past, it's conceivable that microbial life might have thrived in these geothermal waters, potentially using chemical reactions instead of sunlight as a source of energy. The discovery of these minerals also suggests that, at some point, Mars had underground reservoirs of water. On Earth, such reservoirs can host a diverse array of microbes. Perseverance's findings strengthen the case that life could have survived underground on Mars long after surface water dried up, possibly persisting to this day in protected subsurface niches. What this means for the search for extraterrestrial life. The discovery of organic compounds and evidence of ancient geothermal activity on Mars has profound implications for the search for extraterrestrial life. If life existed on Mars, even in microbial form, it would prove that life is not unique to Earth, raising the possibility that life could be common throughout the universe. Additionally, Mars's past conditions could serve as an analog for icy moons like Europa and Enceladus, which also possess subsurface oceans and potential geothermal activity. Studying Mars and its habitability offers insights into where else in our solar system life might be hiding and what signatures we should look for in those environments. The Martian climate and the role of volatile compounds. Another fascinating element of Perseverance's discovery relates to the role of volatile compounds in Mars's climate. Volatile compounds, such as carbon dioxide, methane, and water vapor, are crucial for the formation of a stable atmosphere. On Earth, methane can be produced biologically by microbes or through geological processes, and the discovery of methane in Mars's atmosphere has puzzled scientists for years. Perseverance's instruments detected fluctuations in methane levels in Jezero crater, raising questions about whether this methane could have biological origins. If confirmed, this could be one of the most compelling indicators of life on Mars. However, even if the methane was generated geologically, it suggests that Mars has an active climate and may still experience underground chemical reactions that could be relevant to understanding its past habitability. Implications for future Mars missions and human exploration. NASA's Mars Sample Return mission, set to retrieve rock and soil samples collected by Perseverance, is now even more critical. These samples, when brought to Earth, can be analyzed with more powerful laboratory instruments to determine the exact origin of the organic molecules. By studying the isotopic ratios of these compounds, scientists could determine whether they were formed biologically or through abiotic processes. The discovery also highlights the importance of exploring Mars's subsurface, where life could potentially exist today. Robotic missions capable of drilling into the Martian crust and analyzing deeper samples would provide invaluable data on whether Mars's interior remains habitable. This is particularly relevant for human missions, as underground habitats could protect astronauts from Mars's harsh surface conditions, including cosmic radiation and extreme temperatures. The philosophical and scientific implications of finding life beyond Earth. If Perseverance's discovery ultimately leads to evidence of ancient microbial life on Mars, it would reshape our understanding of biology and our place in the universe. Life on Mars, if found, would imply that life might emerge whenever the right conditions exist, making it a fundamental part of the universe rather than a rare anomaly. This realization would encourage further exploration of exoplanets in search of habitable worlds, as well as a deeper inquiry into life's origins and potential diversity. In addition, the implications would extend to philosophy and religion, challenging humanity's view of itself as a unique and solitary existence in the cosmos. A discovery of Martian life could redefine what it means to be alive and raise ethical considerations about our responsibilities in interacting with extraterrestrial ecosystems. Looking forward, a new era of Mars exploration. With Perseverance's groundbreaking findings, we are entering a new era of Martian exploration. The rover's success has demonstrated that Mars is an active planet with a complex history of water, organic chemistry, and potentially geothermal activity. Each discovery builds upon decades of Martian research, providing a clearer picture of a planet that once harbored water and essential elements for life. NASA, in collaboration with the European Space Agency, ESA, is pushing forward with the Mars Sample Return mission, which aims to bring Perseverance's carefully collected samples back to Earth. This ambitious endeavor will enable scientists to conduct high-resolution analyses, providing definitive answers to questions about Mars's past environment and the origins of the organic molecules found there. In parallel, New technologies are being developed to search for life on Mars more comprehensively. Advanced rovers, landers, and orbiters are in the pipeline, and with the possible addition of manned missions, we may soon witness a dramatic leap forward in our understanding of the Red Planet. Conclusion: Perseverance's discovery, the dawn of a new understanding. The discovery made by NASA's Perseverance rover represents a watershed moment in planetary science and astrobiology. By uncovering organic compounds, signs of ancient water, and potential geothermal activity on Mars, Perseverance has provided the most compelling evidence yet that Mars could have once supported microbial life. This mind-blowing discovery challenges our preconceived notions of Mars as a barren desert and opens up new possibilities for understanding the origins of life. As humanity stands on the cusp of interplanetary exploration, Perseverance's findings remind us that the cosmos is filled with untold mysteries waiting to be uncovered. Mars, our nearest planetary neighbor, may soon reveal answers to questions that have puzzled humankind for centuries. The search for life beyond Earth is no longer confined to the realm of science fiction. With each new discovery, we are closer to understanding the profound complexity of our universe and our place within it.